Let's explore for loops in Go. For loops are the only loop statement available in Go. Here's a complete guide to using for loops effectively in Go. Let's understand the basic structure of a for loop. This is the classic three-part structure. The syntax is for followed by an initialization statement, then a condition, and finally a post statement, all enclosed in curly braces. For example, for i:= 0, I less than 5, I++ inside the loop, fm to print an I. This loop initializes I to 0, continues as long as I is less than 5, and increments I by 1 after each iteration. The components are initialization, i:= 0 condition, I less than 5 post statement, I++. Go's for loop can also mimic a while loop from other languages, requiring only a condition. Here's an example. First, we declare a variable count == 0. Then we create a for loop with the condition count less than 3. Inside the loop, we print the count using fmt count, and then increment count by 1 using count++. Some key points to note. There is no initialization within the for loop statement itself. Only the condition is specified. Manual increment or decrement is required within the loop's body. It functions similarly to a while loop in other languages. An infinite loop runs indefinitely because it lacks a terminating condition. Here's an example. For followed by empty curly braces. Inside the loop, fmt running. Then an if condition to check if some condition is met, and if so, a break statement to exit the loop. Important points to keep in mind. No condition is specified, so the loop runs forever unless explicitly stopped. Use break to exit the loop based on a certain condition. Infinite loops are commonly used for servers or daemons that need to run continuously. The range keyword in a for loop is used to iterate over elements in arrays and slices. In this example, we have a slice of strings called fruits : square bracket string, curly braces, apple, banana, curly braces. Now, to loop over this slice, you can use the following code. For index, value : range fruits, curly braces, fmt, println index, value. The range keyword returns both the index and the value for each element in the array or slice. You can use an underscore to ignore the index if you only need the value like this. For _v: range fruits. Also, you can retrieve only the index like this. For I: range fruits. The range keyword can be used to iterate over maps as well, providing access to both keys and values. Here's an example. We have a map called scores: map of type string to int, curly braces, Alice: 95, Bob: 87, close curly braces. To iterate over the map, use for key, value : range scores, curly braces, fmt, println key value. Key points about map iteration. Range returns the key and value for each entry in the map. The order of iteration is not guaranteed for maps. If you only need the keys, you can use for k: range scores. Similarly, to retrieve only the values, you can use for _v: range scores. Go provides break and continue statements to control loop execution. The break statement exits the loop completely, while the continue statement skips the current iteration and proceeds to the next one. Here is an example of break. For I: 0, I less than 10, I++ curly braces if I = 5 curly braces break, close curly braces fmt, println I. Here is the continue example. For I: 0, I less than 5, I++ curly braces if I = 2 curly braces continue close curly braces fmt, println I. Key points. Break exits the loop. Continue skips the current iteration. These statements work with all loop types and are essential for implementing conditional logic within loops. Let's summarize the different types of for loops in Go and their key characteristics. The loop types are basic for loop with initialization, condition, and post statements, while style loop with only a condition, infinite loop with no condition, range loop for iterating over arrays, slices, and maps. Key takeaways: for is the only loop statement in Go. It offers multiple flexible forms to suit different scenarios. The range keyword simplifies iteration over collections. Break and continue statements provide control over loop execution. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.